All right, hey Michael and whoever is watching this video, what I'm going to do is to start with, there was part of the notes for section 6.4 that we did not go over. I don't ask you a whole lot of questions on it, but it is important to just kind of go through this really quick. So don't do anything with your paper right now. The paper that you have in front of you is 6.6. We skipped section 6.5. So you're just going to look at this and we're going to go through and you're going to help me graph just these two and then we'll move on to 6.6, okay? Because I do think it's important for you to look at what the graph of a log does. I'm not going to make you graph it yourself, hence the homework assignment we've already turned in. Like, you don't need to do anything with that. But we do need to look at what the graph of a log does, okay? So help me go through this, and this is example 2 on the 6.4 notes. You don't need to get this out. You don't need to fill this in, whatever, okay? Just help me through this. We are trying to graph log base 5 of x, okay? All right, at the top of section 6.4, I did this to you, and I said, like, log base 10 of x is the inverse of 10 to the x power, right? Log base 2 of x is the inverse of 2 to the x power, etc., right? Okay? So if I'm looking at log base 5 of x, this guy, his inverse would be 5 to the x power, right? Does that make sense? Okay? 5 to the x power. Now, if we graph him, let's plot some points. I'm going to go from -2 to 2. So -2, -1, 0, 1, and 2. All right? Help me out here. If I plug, let's start with 0. If I plug 0 in, 5 to the 0 power is 1. 5 to the first power, 5. 5 to the second power, 25. You need to listen or I will move you. Or you can stay after school and we'll do it then. Listen. 5 to the negative first power is 1/5, right? It just flips it. 5 to the -2 power flips it and squares it, right? 1 over 25. Okay, now if I graph this, -2 is at 1 over 25. -1 is at 1/5, and then it does this, right? 1 is at 5, 2 is at 25, which is all the way up there. This is what my exponential function looks like, right? We know, ooh, let's try that again. Okay, so, yeah, kind of. We know that so this is what 5 to the x power looks like. This is 5 to the x power. I want to graph log base 5, okay? So Reese says, we know this dotted line, he's flipped over top of that. But we also know that if I graph these points, it will give me that function, right? If they give me points and I'm trying to graph the inverse of those coordinates, what do I do to the coordinates? Switch them around, right? So rather than graphing 2, 25, I'm going to graph 25, 2. I can't graph 25, 2. It's all the way over here. This one would be graphing 5, 1. I can graph that, right? 5, 1 would be here. Okay, this would be the graphing 1, 0, which is here. This would be graphing 1/5, which is over here, and -1, then 1/25, like this. This is what a log function looks like, okay? Now, one more thing to include, okay, this exponential function, the one that we're used to graphing, he has a horizontal asymptote here at 0, right? Do you know what happens to the log function, which is this guy? He's going to have a vertical one at 0, right? Because this line is getting really, really close to 0 down here. Do you see that? So that's the difference. The log function is going to look kind of like that. But they are flipped across that dotted line, right? Okay? Same thing over here. What's the opposite or the inverse of log base 1/3 of x? What's the inverse? Yeah. No. You're right. 1/3 to the x power. That's what the inverse would be, right? That's an exponential function. Okay, let's graph some points here. We're going to go fast. -2, -1, 0, 1, 2. What's 1/3 to the 0 power? Let's start there. 1. 1/3 to the first power? 1/3. 1/3 to the second power is 1/9. Okay, what happens to the -1 power?
3.
Flips it, becomes 3. To the -2 power would be 9, right? Okay, so -2 is at 9, which is up here a little ways. -1 is at 3. 0 is at 1, and then we go like this, something like that, right? Okay, what's the difference between this one and the last one that we graphed? Whoa. This one is what type of function? This is 1/3 to the x power.
Okay.
Why is it going down?
Okay.
This is a decay because it's 1/3, right? Okay, it's going downhill. Versus 5 to the x power is growing. It's going uphill, right? Okay, this one's going downhill. All right, now we want to invert or reverse these pieces right here. So instead of 1/9, 2, I'm going to go, instead of 2 1/9, I'm going to go 1/9, 2, which is this guy right here. Okay, I'm going to go 1/3, comma 1. I'm going to go 0, 1. No, I'm going to go 1, 0. Blah, blah, blah. I can't do this. I'm going to go 3, negative 1. 3, negative 1. I'm going to go 9, negative 2, like this. And this is what my log function looks like. Let's see if I can graph it. Something like that. Okay? That looks kind of weird. But that's what a log function does. It looks very similar to an exponential function, but it curves the other way, right? And if I put my dotted line in there, does it look like he's flipped over that dotted line? Kind of looks like a bowl, you know, like just moved over, right? He kind of looks okay. My drawing is terrible, but anyway, he looks pretty similar on both sides. If I did draw my lines nice and straight, which I didn't. But that's what a log function looks like. Very similar to an exponential function, still flipped over that dotted line because they're still inverses of each other, right? Okay, what?
Would the first example be like a boomerang?
Kind of, yeah. So that's what Ellie Manger said. She said, hey, look at this one. It kind of looks like it's a boomerang. I said, yeah, but that's two functions that we graphed. So these two functions put together kind of look like a boomerang, right? Okay, but that's two functions rather than just one function. Nope, it's 1/x is the boomerang. Yeah. What? Reciprocal. Yeah, reciprocal. Or sometimes they'll call it, instead of reciprocal, they'll call it an inverse function. Reciprocal or, yeah, reciprocal or inverse, one of the two. Yeah, right, exactly. Yeah, they're inverse functions. Perfect. Okay. All right, so that was kind of the little bit of 6.4 that we didn't go through. I'm not going to go through this backside and talk about anything on that, but let's go to 6.6, which is the next section. We skipped 6.5. What other one did we skip? 6.3. We skipped 6.5 and 6.3. I got to erase some stuff. Sorry, hold on. Give me a moment. We are only today going to go through example 1 and example 2. That's it. Like games. Example 1 and example 2.
Are we gonna do more?
We're gonna do more of it tomorrow. Yeah. Okay.
So we're not gonna finish this today?
We won't finish that today. Correct. Okay. Can you wait like 5 minutes? We'll be done in like 5 minutes. Okay. All right. 6.6. Properties of logs. Okay.
I'll take time.
We need to know how logs operate in order to be able to solve things later on in this chapter. Okay. And what we've been doing in the last two sections are going to carry over into this, okay? Just a little bit further than that, like we're doing one more step than that, okay? All right, properties of logs. We need to know that, like, when we take logs and we're adding them together like this in example 1, like, how do we do that? Like, how do they operate? How do they work, okay? And here's how they work. Go up to this box. Actually, go over here and circle the word product, okay? Now go down to the next box and circle the word quotient, okay? There are different rules when you're doing a product versus doing a quotient. These are the two that we're going to learn today. So this is property number 1. This is property number 2. There are 2 more properties because there's 2 more boxes. We'll learn those 2 tomorrow, okay? So property 1, property 2. The first one says product. And what does it mean when you're doing a product? You're multiplying. This is a multiplication problem, okay? Product means multiply. Boys, are you listening?
Yes, ma'am.
Okay. Product means multiply. Times, right? Those are things that we are multiplying. Okay? Division is quotient, right? This means division.
Whoa.
And that is divide.
You have to be above 5 foot.
Quotient means divide. Product means multiply. Happy with that? Okay? Good? Product, multiply, quotient, divide. Here we go. I'm going to show you an example over here of how logs operate. Ready? Pay attention really close to this. Write this off to the side over here. Let's say I'm doing like x squared times x to the 3rd power, right? This means multiply. And we're going to simplify this thing, and we're going to see what happens. Okay, so x squared times x to the 3rd power.
X to the 5th?
Is it 5 or is it 6?
5 because you add.
Okay, what's the difference? Let's do this one up here. Which one is that?
That's 6.
This one's 6. Okay, so down here, this one is 5 because you are
Adding them.
adding them. You take 2 plus 3 and that gives you x to the 5th power. So when you are multiplying exponents, you actually, or when you're multiplying 2 things together that have exponents, you actually add the exponents. That is exactly the way that logs operate. So when you are multiplying or when you're doing a product, that actually means you are going to add them. Okay, and I'll show you kind of how that works.
I was kind of.
Okay, so multiply in the log world. Taking a product in the log world means that you are going to add them. Okay, let's show you an example over here. Okay, so look just at these two pieces right here. Just look at those two pieces. Okay, we have a single log. We have one piece, and we are multiplying those things together. Do you see how that works? We have one log, and these two things are being multiplied. Okay? And what we're allowed to do, this is a property that says we are allowed to break that into two logs, but when we do that, it switches to plus, right? Okay? So take a look at the things that we broke, right? This is log base 3 of these two multiplied together, okay? We switch them and we break them into two logs, and we break the 10 and the 100 down, and we put a plus sign in between them. Do you see how that works? So now we have two pieces that are plus instead of one piece that is multiplied. Okay? It works the opposite as what we were doing up here. Here we had two pieces that were multiplied and one piece that was plus, right? Here we have two pieces that are plus and one piece that is multiplied. Do you see how that works? Okay? We'll do an example of this. It takes a little bit of to get the hang of it, okay? So here we go. We are trying to put this into a single log, which means one piece, right? One piece. I want to combine these into one log. And the base of that log is going to be 4 because it's log 4 and log 4. So we want a log base 4, okay? In the first piece, I was taking log of 2. In the second piece, I was taking log of 32. And because I'm adding those together and I combine them into one, add means
34.
multiply. And I'm going to take 2 times 32, which in turn will become log base 4 of 64. That's what it will be, right? Do we see how that works? Plus means multiply. When you combine them into one, you're going to multiply them together. When you separate them apart, you're going to add, right? Add, multiply, add, okay? Now they want us not to just stop there. They say, okay, simplify with that. What is log base 4 of 64? How do you solve that?
64 power?
What?
It'd be 4.
So,
X equals.
we're going to do the same thing as what we did in the last section, right? In section 6.4, we set it equal to 0, did we not? Or excuse me, equal to x, did we not? Okay, then we switch it around. So this becomes 4 to the x power equals 64, and then we solve for x. How many times do you have to take 4 times itself to get 64?
4.
3.
3, right? 4 times 4 times 4 is 64, exactly. So x would equal 3, and now we're done, right?
Can you zoom out a little?
I can. Okay. So multiply means add means multiply. When we're breaking apart and putting together, that's how that operates. Yeah? Okay. Good?
Hang on. Okay.
Okay, I'm going to do this. I'm going to change this example here. Change this. This is a typo. Just put 9 in there. I think these were supposed to be parentheses. So let's just put 9 in that spot. So instead of 192, I don't know why it's 192, put 9 in there. Log base 4 of 9. Okay? Let's change them to a 9. All right? Here's what we know. They're going to give us this information. They give to us that log base 4 of 3 is something, right? We know the value of log base 4 of 3. And we're wanting to use that information to find what log base 4 of 9 is. Okay? Well, what is 9 in terms of 3? It's like 3 times 3. I'm going to write it as 3 times 3 rather than 3 squared. Okay, we'll get to 3 squared here like tomorrow. We'll talk about 3 squared. Okay, I'm going to write it as 3 times 3, right? Okay, so we're multiplying the 3 and the 3 together. And if I want to break those down into 2 pieces, right? Multiply means add. Okay, so that now is going to become 2 logs. Log base 4 of 3 plus log base 4 of 3. Right? There's 2 logs and multiplied together as 1 unit. Now splits into 2 logs added, right? Okay, but what is the value of log base 4 of 3? They tell us right here, log base 4 of 3 is this, right? Log base 4 of 3 is 0.7925, and I'm going to add to that another 0.7925. Do you see how that works? Okay, 0.7925 plus 0.7925, which is like, I don't know, 1.5850. Check me.
Where are we at?
No.
25 plus 0.7.
You minus 150 from.
It's 1.585. Yeah.
Yeah, very good. Okay, but do you see how we add those together? Multiply means add. So if we're breaking it apart into two pieces, we have to add those two terms together, add those two values, okay? We're going to do the same thing here, but this one is a quotient, okay? If multiply means add, what do you think divide means? Subtract, and I'm going to show you
Can
why.
you scroll up just this smidgen?
Like that? Can I just like zoom out like that? Okay. Divide is going to mean subtract, and here is why. Okay, I'm going to go over here and let's do an example. If I would give you, let's say x to the 5th power divided by x squared, right? You're dividing. What do you do with 5 and 2? You subtract them. Is x to the 5th power divided by x squared equal to x to the 3rd power? Yeah, that's what it is, because you're subtracting the 5 and the 2. That's the way that they operate. So in the world of logarithms, divide means subtract, right? So here, what we have going on here is we have one log, and that is divide, and we break it into 2 logs, and when we do that, we subtract them, right? 2 logs subtraction is the same thing as 1 log divide, right? Divide means subtract. Subtract means divide in log world, right? When we're breaking apart and putting together, okay? So this one, express those as a single log. What does that mean? Put them together. So we want 1 log, and the log is going to be log base 2, right? These are each log base 2s, okay? Here we were taking log base 2 of 32, and we were taking log base 2 of 4, okay? And we were subtracting in between them, which means when we put them together, we are going to divide. Subtract means divide. What do we divide?
32 divided by 4.
Okay, how do you know the 32 goes on top?
Because it's the first number.
Because it's the first number. The first number always goes on top. 32 divided by 4. Okay, what is 32 divided by 4?
8.
Log base 2 of 8. That's how this simplifies, right? Okay, now they want us to keep going. How do we solve what log base 2 of 8 is?
2 of x.
Yeah, we set it equal to x first, and then we make it an exponential function, just like we were doing in section 6.4. That says 2 to the
X equals 3.
x power equals 8, and we know that x then has to be 3. Yeah? Make sense? Yeah.
Can you zoom up?
I feel like this was a lot better received 8th period than 6th period. And normally, I'm not going to go there.
Was
What?
6th grade, like, yelling at you 'cause you
No, 6th period was like, I have no idea what you just said. That was Chinese.
Wow.
And you look
That
like
was
you're
mean,
getting
Mrs.
this a little bit
Thomas.
better.
That's
Anyway,
pretty simple, not gonna
it's not too bad.
did?
What?
She said
King
6th grade.
Kong.
I said 6th period didn't do well with this.
See, I can
You know,
speak that
sometimes it's just
language.
wait.
Speaking Isaac, right?
Just wait.
Oh,
Go.
goodness.
Go to,
Oh,
I'm going to erase. Okay. Go to your homework assignment skills practice. Your homework is just to do number 1 through 4. You are just doing 1 through 4. Okay?
On the scale
Let's
of
get you a little start though on skills practice. Just 1 through 4. Don't cross any of the other ones out because we'll do them eventually.
What about-
Okay? Just 1 through 4. Just wait. We're not going to do anything on practice yet. Just 1 through 4. Tomorrow we'll do the rest.
Do the first one.
Or whatever.
together.
Okay? 1 through 4. Let's do the first one together. The stuff that they give to me. Do you see where that's at?
Wait, on skills
They
practice?
give to me log base 2 of 3 and they give to me log base 2 of 5. Skills practice. Log base 2 of 3 and log base 2 of 5. I know what that is. All right? I want to figure out what 25 is. So I have to write it in terms of one of those. Right?
5.
5. So Josie says that log base 2 of 25 is the same thing as what?
25 or 5 squared.
5 times 5. Okay? But multiply means?
No, add.
Add. Multiply means add. So if I break these into 2 pieces, I have 2 logs, log base 2 and log base 2.
Base 2 of 2.32.
No. Log base 2 of 5
And then log base
plus log base 2 of 5. But what is log base 2 of 5?
2.3219.
2.3219 plus
Wow.
2.3219. Does this make sense?
Yeah.
Okay.
Just add them both.
So you're just adding those together. 6.6
It's
438.
4.6.
No, 4.6438. I don't know why I'm trying to add numbers, whatever. 4.6438. Is that correct?
Yes.
Yeah. There you go. Okay? Happy with that? Does this make sense?
Yes.
Now, number 2 is 3 over 5. What does that mean?
Divide.
Divide, and when you're dividing, you
Subtract.
subtract. So figure out how you're going to break that down into pieces and figure out what numbers you need to subtract and that stuff, okay? All right? Write it out. It's not difficult if you understand what's going on. All right? You can get a negative number. Yes. What? Okay. I'm going to stop the video. Try to get through these. This is hard stuff because you've never done this before. After you see it, it makes a little bit of sense, but whatever. Okay. Goodbye, Michael.